Welcome to my channel, The Proper Guidance. This is my second class of CBSE students, class 9 geometry. In the previous video, we have discussed about Euclid's geometry, and today's topic is chapter number 8. And in this chapter, we will learn about quadrilateral, and rather we will discuss about quadrilateral. Okay, so what is the definition of quadrilateral? See, when a geometric figure has 4 sides, then we will say it that it is a quadrilateral. This is the basic definition of quadrilateral, that a geometric figure will have 4 sides. Clear? In the previous class, we have discussed about triangles, and now we will discuss about the quadrilateral. Now see, here are some figures, geometrical figures. A, B, C, D, this is a geometrical figure, and here AB is one side, BC is second one, CD and DA. 4 sides are here in this picture, right? So this is a quadrilateral. And here it is another picture. Here is in this geometrical figure, we have seen that there is one side AB, BC, CD and DA. So it will also be said as a quadrilateral. Why? Because this geometrical figure consists of 4 sides. Clear? And now the most important property we will discuss, that is angle sum property. What do you mean? Angle sum property of a quadrilateral. In the previous class, we have discussed about angle sum property of triangles, right? And here we will discuss about the angle sum property of a quadrilateral. What does it mean? This is nothing but sum of 4 angles. When in this picture you have seen that there are 4 sides, so it will make 4 angles in this figure, right? Angle A, angle B, angle C and angle D. And same in this picture also, there are 4 angles. 4 sides will make 4 angles, and they are angle A, angle B, angle C and angle D. And these 4 angles, when we will sum of these 4 angles, we will get the value 360 degree. This is our basic property we have to use in the further theorems. Clear? So please note it down that sum of 4 angles is equal to 360 degree, and this is known as angle sum property of a quadrilateral. Okay, then we will learn about some various types. There are so many types of quadrilateral. So many types. Here are the figures of those types. Look at this picture first. A, B, C, D. This is known as trapezium. Now, why you should tell this as a trapezium? Why? Because look at this picture. There is AB and CD. They are not equal, but they are parallel to each other. AB parallel CD, not AD and BC. They are not parallel lines. They may be equal or not. When these 2 sides are equal in nature, then this is called an isosceles trapezium. Okay? And here this trapezium, this is only called a trapezium because a pair of sides of this quadrilateral is parallel in nature. So we learn about this, that this is a trapezium. Next figure, here it is. This is known as a parallelogram. What is a parallelogram? See, here side AB parallel to CD, AB parallel to CD as well as AD is parallel to BC. This figure holds this property. Again, we can say that if any figure in any geometrical figure which consists of this property will be known as parallelogram. Clear? And then comes rectangle. We all know about this figure, rectangle, right? So what is a rectangle? This is also a parallelogram, but some specific feature is here. That is, these angles, these four angles will be 90 degree. Okay, so this is a rectangle, these sides are equal, opposite sides are equal and parallel to each other, and each of the angles of a rectangle must be 90 degree. And here is a square. This is also a special case of parallelogram. Rather, you can say it that this is a special case of rectangle also. Why? Because all four sides are equal. In a square, we can see that all the four sides are equal and all the angles, all its angles means each of the angle should be 90 degree. This is the feature of a square. And then comes rhombus. Rhombus is also a special type of parallelogram because AD parallel to BC and AB parallel to DC. And the special nature of rhombus is all the four sides are equal but the angles are not 90 degree. This is the basic difference between a square and a rhombus. What is the difference? Here all the sides are equal, here also all the sides are equal, but each of the angle in a square should be 90 degree, where in a rhombus all the equal sides will be equal but the angles are not to be equal to 90 degree. Clear? So this is the basic difference of a square and a rhombus. And now look at this picture. This is known as kite. Look here. This side and this side, that is AD and CD, are equal. AD equals to CD and AB equals to BC. When you get this type of quadrilateral, this will be known as a kite. Clear? So these are the various types of quadrilateral. So what is the definition? This is very introductory and basic class of quadrilateral, chapter number 8, that when we are going through the chapter, we should go through the definition first, then their properties and the various types. So here is a recap of this class that we have learned about the quadrilateral. What is it? It means that a geometric figure which has four sides will be known as quadrilateral. It may be of different shapes, right? It may be of different shapes, but whatever may be the shape, angles and property of a quadrilateral tells us that the sum of four angles will equal to 360 degree. This is the very vital point. We will use this point in rather mathematical question and answer and all in the theorem also we use it. Okay, so please note it down. This is a very important point, that sum of four angles of a quadrilateral must be equal to 360 degree. Okay, and then comes various types. What are the various types of a quadrilateral? There are so many types. First, I have discussed about the trapezium. What it means, that any pair of this geometrical shape must be parallel in nature, and the non-parallel sides is not mandatorily equal in nature. They may be equal or not may be equal. Okay, they may be or may not be equal to each other. This is trapezium. Okay, and then we see here the geometrical figure known as parallelogram. What it means, that opposite sides are parallel in nature. That type of figure is known as parallelogram. Okay, and now we will discuss about three: the rectangle, square and rhombus. What are they? They are spatial parallelogram. They consist of some spatial feature. Okay, they all are parallelograms. A rectangle must be a parallelogram because their opposite sides are parallel to each other. But the spatial properties here is that the angles, each of the angle of rectangle must be equals to 90 degree. And here it is the square. Square is also consist of four equal sides and four equal angles. They must be of 90 degree. Okay. And the rhombus. Rhombus is having four equal sides, but the angles are not 90 degree. And here is the kite. Okay. Now we will learn about properties of parallelogram. There are so many properties of parallelogram. Here Now we are going to prove theorem number 8.1. Look at the board. Properties of parallelogram. Now there are so many properties of parallelogram. The first one is a diagonal of a parallelogram divides it into two congruent triangles. Okay. Now what is a theorem? Theorem is this line. Okay. This is given and we have to prove this, that this is a true fact. You have to prove this one. And when we are prove something, this is known as the theorem. In the previous class, I have discussed about postulate and axioms, right? In those postulate section, what we have learned that was the universal truth, which was taken as universal truth. But here it is, we have to prove this statement. What is given, that given statement we have to prove with the logic, with some geometrical properties and so many logics are here. Now, this is theorem number 8.1. This is the statement of that theorem. What is it? A diagonal of a parallelogram divides it into two congruent triangles. And in my previous video, I have also discussed about congruent triangles. What are the properties we have to see to show that two triangles are congruent, right? So there are so many properties. Those who are new to this class, please look at from that previous video. Okay. So continue. See, here is the parallelogram ABCD, and I have drawn AC, the diagonal. You may take it BD, whatever. You may draw AC or you may draw BD as the diagonal, because there are only two diagonals in a parallelogram, right? Now see, what is the proof? A diagonal of a parallelogram divides it into two congruent triangles. So when you draw this diagonal, you get two triangles, right? Angle ABC and the triangle ACD. Now see here, let ABCD is a parallelogram. Here we draw the diagonal AC. We have to prove that triangle ABC congruent to triangle ACD. Angle ABC congruent to ACD. Now, look here in the picture. See, these two angles, this one and this one, ACD and BAC. These two angles are equal in nature. Why? Because this is a parallelogram, and what we have learned that in a parallelogram, opposite sides are parallel in nature, and when some transversal are passing through two parallel lines, we get to internal angles, right? These angles should be equal in nature. These properties are all discussed in my previous class. You people, please follow this class. Okay, then look at this proof. Now see, these two angles are equal in nature, and applying the same logic, you can say that these two angles will be equal in nature, because AD and BC are parallel in nature and AC is the transversal. And here is the writing of this proof. From triangle ABC and triangle ACD, we can write that angle BAC is equals to angle ACD, BCA equals to angle CAD, and AC, this is the common line, so AC equals to AC. And from the properties of congruent of triangle, we know that two angle and side. Angle side property, we can say that these two triangles, triangle ABC is congruent to triangle ACD. What we have to prove, right? Now see, this is one part. When we draw only one diagonal, we get this one, right? In the same way, we can draw BD diagonal or diagonal BD and prove that when you draw diagonal BD, you will get these two triangles, right? ABD and BCD. ABD and BCD. And you can prove that with the help of the same logic, we can prove that triangle ABD is congruent to triangle BCD. So the theorem is proved. What is our first theorem? About parallelogram, that a diagonal of a parallelogram divides it into two congruent triangles, right? The students who are from Hindi medium, I am just telling this proof in Hindi also that here देखो ये जो ABCD पैरेललोग्राम है उसके बीच में जो AC डायगोनल अगर तुम खींचते हो तो दोनों जो ट्रायंगल तुमको मिलते हैं वो होगा एक दूसरे के कॉन्ग्रुएंट, राइट? सो प्रॉपर्टीज वी अप्लाई, तुम्हें अप्लाई करना है कि कौन सा एंगल किसके साथ समान होता है, उसके बाद तुम ये कह पाओगे कि ये कॉन्ग्रुएंट होगा। तो एंगल एंगल सम प्रॉपर्टी, एंगल एंगल सम प्रॉपर्टी, this angle, that angle and the common line. Okay, we get these three things in this portion and you can say that तुम कह सकते हो कि ये दोनों ही triangle congruent in nature. Okay, and in the same way you can draw BD. अगर तुम BD diagonal को ड्रॉ करते हो तो उसके बाद एक ही उपाय से, इसी उपाय से ही तुम ये कह सकते हो कि जिस तरह ये दोनों ट्रायंगल आपस में कॉन्ग्रुएंट हुआ था उसी तरह ट्रायंगल ABD और ट्रायंगल BCD भी एक दूसरे के कॉन्ग्रुएंट ही होगा। ओके, सो दिस इज द फर्स्ट थ्योरम एंड प्लीज स्टूडेंट्स if you like my class, give a thumbs up and please share it and subscribe my channel. I am trying my level best to share my knowledge and I think you should also be helpful from my class. Okay, and if there is any query, please comment me. I will clear the doubt and make another doubt clearance class for you. Okay, thank you.